부산 촛불로 페널티 골 넣었으니까. 이 축구가 저는 비단
please mute yourselves. I'll begin in 5 minutes. Sorry for the delay. All right, thanks for waiting. Let us begin. So can you turn on your videos for whoever as possible. Let me turn on mine as well. All right, good to see you. Okay, so let us begin. Okay, so hopefully you had a great holidays. And let us begin. All right, so thanks for waiting. By the way, I just uploaded the slides. Sorry for keep you waiting. And on KLMS, you can download the slides. Okay, I just wanted to make some change at the last moment. So, okay. So what are we going to talk about today is shells and commands in Linux. So basically, I know that some of these let me mute some of you guys. Okay, if you haven't mute yourselves, please do so now. Okay. So so again, so this lecture will be about some Linux commands, and I know that some of the commands are the things that you have probably used already for homework 0, for EE209, and as well as homework 1 for this class, right? But the idea, I know that we are aware that you have already used some of the commands, but here the idea is to give you overall overview of different commands. You probably have used, you probably have used some of the commands, but you probably have used it, without, without knowing the big picture, right? You probably have just Googled it and used some of the commands. That is great start, but we wanted to give you some big picture of different kinds of commands, different things you can do in using the command line prompt. But don't get me wrong, okay? I'm not trying to deliver every single command that we can use on Linux, right? Just like when you learn programming, in order for you to learn, get used to different commands, the best way, the only way is for you to do it yourselves, right? But here, what you need to learn in this class is the overview, right? What kinds of command prompts are there, right? What are the things that you need to know, right? What are the important commands that you might need to know throughout the lecture, throughout the semester, right? Okay. All right. So after this class, my suggestion is to go over and try different commands yourselves. It will be pretty fun. Okay. There are tons of different commands in Linux. There's no way for us to cover all of it. As you go through the semester, you will find yourselves using some commands more than the others, right? And there are many different ways to achieve the same goal. Okay, there can be many different commands to do the same thing, actually. And then which one of the commands that you use is really your choice, right? Some people prefer one command than the other. Okay, so those are the things that that really follows your preference. Okay, and which you will build up as you move along through the semester. Okay, all right. So different people have different preferences, right? Okay, to do the same thing. Okay, let's move on. So with that in mind, let's move on. Okay. So the command line prompt are when we're doing command line prompt, we're using something called shell, right? We've talked about what shell was in the last briefly in the last lecture, right? Which is a program that takes commands and asks the OS to execute them, right? What did I say in the last lecture? It's probably been a few weeks, so you might not remember. I've told you, I've described a shell as an interpreter, right? So it interprets, gets the input from you through the command line prompt, and then it interprets, understands what you're trying to say, and then execute whatever you ask them to do, right? That is what shell is doing. So so it's a command line interpreter. There are different types of shells, and we're basically using bash. And this is the command line prompt, right? You probably have experience in doing this, right? Okay. And this is called the prompt, right? So this is called the prompt. The format is there's a username, okay? And there's a server name and the directory. Sorry. And the directory, okay? This will, so let's look at one by one, okay? You probably have not, you probably have seen this when you're doing homework, but you probably have not understood it, right? Unless you have experience, right? So we'll go through one by one. Okay. So the first is a username, of course, your ID. Okay. Of course, this is a name but for you guys, it's probably student ID, right? Okay. And this is a server name, right? And this server name for in this example is a ELAB 5, but note that we are using ELAB G12 and ELAB G13, right? Okay. All right. Of course, you can customize this prompt, okay? But I don't see why you would want to customize it in this semester, okay? You can customize it, but the chances that you won't. Okay. So this is the default setting in the bash. So and this is the format. Okay. All right. So this is the first thing that you see on the shell, right? Okay. Okay. In a Linux shell, there's something called super user and a normal user. Okay. So super user is the root that can run all commands. So why do we need a super user or a root? Is because, right? Because the root, because of privacy, right? Because of the security, right? Right? Root basically can do anything. As a super user, it can actually do anything. So you can change the file of another user and so on and so forth, right? And you can change the system settings and so on and so forth, where normal user, just like you guys, right, are the normal user, who can only change your files, right? Right? So basically, super user is administrator. Typically, super user is administrator, the one who manages, maintains the server, right? Is the one who used the root or super user account. Okay, so when just as a side note, when people say like your system is hacked, right? A lot of times that means some inappropriate person has the access to root account, a super user account. Okay, a super user does not have to be a root, but root is a super user. Okay. All right. So root can run all commands, can change the system settings, so that it affects all of the users, right? And you can use all commands like shutdown, which stops the OS and turns it off. You can try to use it yourself. You can try to run shutdown yourself with your ID, which won't let you to shut down which won't work because you don't have the right, you don't have the privilege, okay? Because you are a normal user, okay? And how do you know your name? How do you know who yourself is? is the command through who am I. Okay, so if you run a who am I because you log in with this ID right now, suppose you're logged in with Professor Park's ID right now, then this is the ID that you'll get. Okay. Okay. And host name is the way it returns the host name. Okay. Right. And suppose if you're logged in as a root, then if you do who am I, you'll get a root as a result. Okay. All right. So if you are, suppose if you have installed, hopefully you have installed your local Linux on your local machine, right? That's our encouraged scenario, right? As environment, right? If you have done so, then you have the access to the root for your own Linux, right? Right. Of course, you probably don't want to use the root to do your homework. You should, ideally, you should make your own ID under your own ID for you to use on your Linux. Okay, but still, since you're the owner of your own Linux, you have the access to the root, right? All right. So so suppose if you are a normal user and if you want to, if you want to run a command that is only accessible to the super user, then what you have to do is you run a command using sudo. Okay. Okay. So even if you are a normal user, you can do this, and it will actually ask for the root password. Okay. Okay. So if you're a normal user, but if you still want to run a command that is only accessible to super user, what you can do is you can put a sudo, then it will just, if you do this, then it will immediately ask for the password, root password. Okay. Okay. So and so and su is to change the user to another user. Okay. So if you do this, then you immediately change to this ID. Okay. And of course, it will ask for the password of this ID. All right. And if you do su without anything, it actually switches to root. Of course, you will ask for the root password. Okay. So suppose if you want to run this command, shutdown, okay, which is only accessible to root to the super user, right? Then there are two ways. If you're a normal user, there are two ways, right? You can use sudo, which will ask for root password, or you can change yourself to root and then run shutdown, right? Okay. All right. Man is short for manual, right? And it actually shows the manual of the command. So if you're not unsure how to use sudo, then you just put man sudo. Just same for everything. So if you don't know how to use ls, right, which shows the files under a directory, right, then you just use man ls. So if you probably have used this command already, right? If you don't know how to use it, one way to do it is to find how to use it is Google it, of course. But instead of changing your instead of opening the Chrome and then Googling it, what you can do is on the prompt, you can just type this and press enter, right? And this will actually show you all the options and how to use ls, right? This is actually a faster way to search for how to use the ls, right? It applies for any command. So if you're unsure how to use copy, then you put copy here. You're unsure how to use remove, and you put remove, and so on and so forth, right? Just be sure to get familiar with using man command. It will come in handy. Okay. So what is a directory? So directory is Windows actually use the word folder, right? But the Linux uses directory. Okay. So directory is where the program is located, of course, and where do configuration files live, and where can I find the logs for this application? So how the directory is layout, right? Is it is dependent on this. Okay. Some common directories is this is just is a root directory. Root directory is the highest directory. Okay, is the origin of all the directories, right? So directories have tree structure, right? Right. So directory 1, and it has under directory 1 you can have directory 2, directory 3, and so on, right? The original directory is the root directory. Okay. Here, when I say root, don't get confused. It does not mean root user, right? It does not mean the root super user right now. We're talking about the root directory, the beginning directory. Okay. Okay. These are some of the well-known directories under the root directory, right? For example, bin or binary means where the binaries and other executable programs reside. Okay. Many programs can reside in different parts of the system, where this is one of the widely used directory. Okay. And another directory is home. Under homes, under this directory, we'll have the home directory for different users. Okay, we'll talk more about that. I think we've already talked about this. Under home directory, right? Under home directory, we have different IDs. So your ID will be here as well. Okay. Okay. What are some of the commands related to directories and files? In order to list directory contents, you use the command ls. You probably have used it already, right? Where different options exist for ls command, right? If you put L, it's list of files with detailed attributes. And if you do AL, that means A indicates all files, including hidden files. Okay. So if you just do this, the hidden files are not displayed. But if you put A, then all the hidden files are displayed, right? So just like the hidden files in Windows, there are hidden files in Linux as well, right? And hidden files starts with a dot, right? Any file that starts with the hidden dot, named dot, the character dot, right, is a hidden file, and sometimes, therefore, sometimes called dot file. Okay, like for example, some configuration files, right, is typically a dot file. Okay. So for instance, there's something called bash rc file under your home directory, which actually sets the configuration for your bash shell, for your own bash shell, and that's a dot file. Okay, and if you do it if you try it yourself in your home directory, you'll be able to see a couple of hidden files. Okay. All right. Let's move on. So CD is change directory, right? It switches to the current directory to this to whatever directory you put after CD, right? If you don't put anything here, right, it goes to the home directory of this user. So what is the home directory here, right? So this is the home directory, right? For you, it will be mount home and whatever your student ID is, right? Oops. Okay, and if you do this, then this, by the way, this is the current directory. If you just put a dot, it's a current directory. So if you do this and this, that means you change the directory in it to the temp, which is under the current directory. Okay. So when you execute the files on your when you did your homework, right, in both EE209 and 485, you remember putting this and the file name, right? Right? Why? Because this indicates, oops, this file is under the current directory. Okay. By the way, if you put two dots, it's a the higher directory, right? Okay. I think we have a slide on that. Okay, let's move on. Okay. There's another command is a pwb, which displays the current working directory. So the current directory that you are in right now. Okay. Okay. And the cat is it concatenates and display files. So if you put cat file, you can put one file or multiple files. Okay. Right. So for example, if you put cat hello.c, it will just display the content of hello.c on the command prompt. Okay. So if you have two files, for example, hello.c and world.c, then it actually concatenates two files and show the contents of the two files. Okay. And there are less and more commands are similar to cat, but it's a little bit different. You should try it yourself. Okay. Basically, less and more actually it lets you to navigate through the file. Okay. So difference from cat, if you do cat, it just shows the file immediately, right? So if it's a long file, once you do cat, it just passed by the entire file, right? It's hard for you to read. Where less and more, if you do, instead of cat, if you use less or more, so if you use, for example, more actually has a very similar behavior. So if you put less, for instance, or more, then it actually it actually lets you to navigate through the file, right? Okay. Let's see a little bit more into the commands related to directories and files. Okay. There's a make directory and remove directory. Okay. So you can make directory or remove directory. Okay. If you want to remove it, the directory must be empty before empty before using remove directory. Okay. And if you don't want to, if you want to, okay, let me put it this way. And remove, you probably have used it. We have talked about remove before, right? Remove file is by doing this, you remove that file, right? And one very useful option for remove command is /r, not slash, -r, okay? Which indicates the recursive, meaning that it removes all files under this directory. Okay. All right. So what this means, I actually have a slide for that later on, but let me just explain it now. Suppose if you want to remove some directory, right? And if you do rmdir, if it's not empty, you're not able to remove, right? In that case, you can just use this, right? And this actually will remove everything. Okay. All right. Let me move on. So, and move is move, right? Right. Move is move. So how can I explain it, right? So we just move one file to the other place, one file from one place to another, right? Okay. 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 One thing to note here, okay, is one thing to note about move is that it is also used for renaming. Okay. All right. So of course you can do, if you do this, you just move this file to this location, right? Okay. One popular way of using move is to rename a file. Suppose if you want to change the file name of some file, then you can use move, right? So if you do this, you will rename this file as this. Okay, you rename a.text to b.text. All right. Okay, you can kind of immediately see why move can be used as a rename, right? Right. Okay. Copy is a copy, right? The only difference is that the does not remove the original copy. Okay. Okay. Let's look at some other commands. Echo is echo argument. Then it displays the arguments on the screen. Well, I think it's okay. There's one question about what happens if you remove the directory? Which is not empty. If you just if you do rmdir, so the question is, what happens if you try to remove the directory without emptying it? So if you do rmdir, so it will still be there. So you cannot erase it. So if you do this, oops, oh, yeah. So if you do this, right, then if it's not empty, then it'll spit out an error. Right? So if you want to erase anything that is not empty, you'll have to do this instead. Okay, I have an example of this again in the following slide. So let's move on. Okay, and the commands of exit, logout, and control D, it exits the shell from your current session. So if you do this, your shell will just close. Okay. And clear, it just clears the screen. Okay. So easy way to do this is just type it yourself. Again, this lecture is to just give you a high-level overview of different types of commands. What kinds of commands are there, right? Don't try to memorize everything by looking at the slide, right? Much more efficient way is just type it yourself, right? You immediately remember, right? You immediately memorize. So don't try to look at the slide and try to memorize all the commands, right? All you have to do is just type it, right? And type it and try to do it yourself, and you immediately memorize it yourself. Immediately be able to memorize it, right? Okay, and that's faster even, right? Than trying to memorize it. Okay? Just type it. Okay. And there are something called environment variables in shell. Which are the number of variables, some variables, okay, that are used to run the program. Okay, probably doesn't understand at this moment. Once you look at what are the examples of the environment variables, you immediately understand. Okay, for example, path. This is one of the, so there are many environment variables. Among them, one is path. Okay. All right. So it's a colon. What is a path? Is a colon separated list of directories that are that the shell searches for commands. Okay. Let's look at the example here. So if you do echo path, so what is an echo? Is we talked about echo, right? Find it. Okay, here. It's just displays the argument to the screen, right? So if you so if you have tested echo before, so if you do echo, for instance, hello, then it will just print out hello, right? Right. But if you put, for instance, path here, which is an environment variable, this path, the content of this path will be displayed. Okay, because how shell interprets it is that it because there's a dollar here, it immediately knows that this is a environment variable, right? And then it just searches for this environment variable, right? And then displays the corresponding environment variable in here. Okay, let's look at this example here. So if you do echo path, and this is the output, okay? Right, so what does this mean? What this means is that it shows the list of the directories that the shell search for commands. Okay, suppose if you just run something, right? ls, right? For instance, ls in the command line prompt. ls is actually a program itself. There's a program called ls. Just like that, there's a okay. There's a program called ls. Then, when you just type ls, you never have. Think about it. When you type ls, how does the computer know where the ls is? Right? Computer has to know where to look for the program ls. Right? That is set in the variable path. Okay. Whenever you just put in execute some program, right? If you have not explicitly told the computer where the program is, right? Then it will immediately search for the program within these directories. This is actually a multiple directories, right? So it will search for the directories in this sequence. So first search for the file, the program in this binary, okay, binary folder under root, right? and then you'll go through user binary under user, and so on and so forth. Okay. Okay, and there's one question about what if there is more than 2 programs with the same name? That's a great question. Then it follows the sequence. So suppose if you have ls in this directory and this directory as well, then since the shell will look for each directory in sequence, the file in this directory will be executed. Okay, so you can think of it as a priority. Okay, so this folder has a priority over this folder. Okay, hopefully that answered your question. Okay, so oh, this is what it says here. Okay, right. So if you go through all the folders, if it's not there, then it just spit out an error, right? It cannot be found. Okay. All right, and so these are other environment variables, right? Home, this is the location of the home directory. We've talked about what home directory is, right? And there's something called pwd, which is the variable points to the current directory. So, and there's also a program called pwd, right? Which actually shows you the current directory, right? The same thing. So now you can kind of see that there are multiple ways to achieve the same thing, right? Okay. So suppose if you want to know the current directory, okay, we now know that there are 2 ways, right? One is just to do this, and the other is echo pwd, right? There are 2 ways. Just like this, there can be tons of different ways to achieve the same thing. It's just a matter of preference, right? Some people prefer to use some kind of way and then the other, right? That's just your preference. And as you move out through this semester, you'll kind of have your own preference, okay? Right? And old PWD is a previous directory, okay? So you move from one directory to another, then this actually holds the previous directory, okay? All right. Somehow like a back button in the Chrome browser, right? Right. And shell is a location of the current shell program. Okay. So if you want to search for all the environment, display all environment variables, what you can do is you can use this command. Okay. All right. All right. Another command is which. What this is doing is displays the location of the command. All right. So we've talked about ls. Okay. So if you print this, if you type this, you actually see it will just spit out this. Okay. Then it kind of meets what our discussion before, right? It actually shows that ls is under binary folder, right? Under the root folder, right? Okay. Under root, under binary, right? Okay. So this is the root folder and this is the binary folder, right? Okay. This is actually consistent to what we've just learned, right? So ls, if you type ls, it will search for binary folder. It turns out that ls is actually under binary folder, right? Okay. And you can also do which, meaning if you want to know, okay, let me mute. Okay. So if you want to know the location of the which command, then you do this, right? Again, which command and ls command, they're all separate program, okay? Yeah, they are programs by themselves, right? Okay. If you want to, there's a you can, if you want to find the hint option, then you can use H for a lot of different commands. Not all commands have this option, but some commands have H option where so we've talked about man, right? Manual. Manual is a long version. H typically gives you a shorter version of how to use this command. Okay. Cal, by the way, this is shows the calendar. Okay, current date. All right. Okay. So, so I just wanted to, at this point, I wanted to show you one thing, right? That you probably have done without knowing. Okay. So you might have wondered where GCC 209 is, right? So GCC 209 works somehow, right? But you have no idea where it is, right? Right? Okay. So the how do you so it worked for you, right? But you have you don't remember where you don't know where it is, right? Then how do you do this? You just do which GCC 209. Okay. It turns out that that it turns out that the GCC 209 is actually under this directory. Okay. So if you want to, I'll talk more about this in the last lecture of the in the last lecture of this the last slide of this lecture. But if you want to install GCC 209 on your computer, right? I told you that I'll talk about this in the later parts of the lecture, right? This is which will be this lecture. Okay. So if you want to run GCC 209 on your local machine, on your local Linux, what you have to do is you just copy the file, this file. You now know where this file is, right? Oops. Okay. You now know where this file is. All you have to do is copy this file to your computer, right? Or you can write it yourself. Okay, it's a short, very short script, so you can write it yourself. But yeah, or you can copy it. Okay. All right. Okay. Let's move on. So there's one question about what is the difference bin and user bin. So it's a different places where you put the put different executables. And typically bin is the highest priority. Okay. All right. I believe that answered your question. Okay, let's move on. There's another question. Is there any reason why ls and which are located in different directory? Okay. Well, I guess that's a question of the of how should I say it? That's the I guess that's the question of the criteria of putting in a bin and user bin. I think it's just a convention. I think that's a convention as far as I know, but as far as I remember. But let me search for it. If there is a clear cut, I don't think so, but let me look for it, and I'll make a I'll post it on the on the campus wire. Okay. Thanks for the question. Let me write it down somewhere. Okay. All right. So let's move on with the directories. Okay. So directory is a container file of files and other directories, right? It basically have a tree-like structure, as we talked about, right? And so there are some special directory where dot is this directory and dot dot is a parent directory, right? So if you do cd dot, it doesn't do anything, right? Because you just change the directory to the current directory. If you do cd dot dot, it actually moves you to the parent directory, right? And another thing is a dash. If you do cd dash, it actually moves you to the previous directory. Okay. Okay. One quick quiz. How do you move to the previous directory? No, I mean the previous directory. It's a cd. My question is, how is the shell is able to move to the previous directory? Yes. So there is an old path, old PWD, right, which is stored in the shell. So by using that, is able to move to the previous directory, right? So if you remember old PWD, right, stored here, so it is able to move to the previous directory, right? So this is the previous directory is stored here, right, in the environment variable. So it is the shell is able to look at this environment variable and is able to move you to the previous directory. Okay, thanks for all the answers. Yeah, thanks for the active participation. And so anyway, and this is the directory separator slash is the directory separator, and so well. So you can it's optional for the last directory, so it doesn't matter. This is the same as this, so you can actually put this or not. It doesn't really matter. Okay, and it's actually set here. All right. So this is just an example of what happens if you actually go through those one by one. Okay, so I've actually explained all of it. So I don't think there's anything that you cannot understand at this point. Okay. Okay, how to execute the program in the current directory? You probably have done this already, right? Well, so assume you're in the home directory. What do? You just do this, right? But if you just do this, the shell complains. You probably have done this, right? And, briefly in the first in the very initial trial, and you probably failed with this warning, right? With this complaint, and the right way to run it is this. Okay, so if this program is actually in the home directory, then you can do this. Right? If it's the program is in the parent directory, of course you can do this. If it's in the previous directory, you can do this. Of course, right? It's just the combinations, right? Well, you can just do, you can put the entire directory starting from the root. Of course, this works. Full path. Okay. One another way is you can add one very convenient way. So if you don't like putting this, right? I didn't like it when I was a student. I really hated putting this before I always had to put this, and I really didn't like it. I didn't really like to type that in every time. So what I did was actually added this to the path. Okay? You can try it yourself. Okay. There's one question about. Okay. Oh, let me just end this for now. So end my sentence. So if you don't want to do this, one way to do it is to put this in your path environment, right? Just like any other program, right? Then if you just in any other program, if you put the current, let's put it this way, just like any other directory, right? You can put the current path in the path environment. Okay, environment variable. Then after that, all you have to do is just type program. Okay? But this is probably not as simple as you might imagine. So if you want to do it, yeah, go ahead. Okay. Okay. What is our there's a question about what is the default home directory. I don't understand what the default home directory is. Default home directory for all the users is something like this, right? Something like this, right? We've talked about it. Okay. This is the home directory. All right. Let's move on. Okay. And a little bit more about, so a little bit more about the creating and removing directories. I've actually talked about this already, right? I don't think I have to explain it again, right? So if you want to remove it, basically you can, well, okay, I didn't talk about this. So mkdir is a make directory, so you can make a directory, right? However, you cannot make a direct series of directory at once. Suppose if you want to, let's look at this example here. Well, this works, right? However, this does not work. Okay, so it says it cannot make directory, right? So what is the difference here? So you can make one directory at a time, but you cannot make series of directories, right? That's what it's saying. What it's saying, right? So if you want to do this, you just use option P. It's as simple as that. So it works. And then if you want to remove it, okay? If you want to remove it, if you do rmdir, if it's empty, it will be removed. But if it's not empty, it will not be removed. Okay. Not empty meaning if it not empty includes the case where it has another directory, child directory, right? It can be a file or directory, right? So what if a directory contains a file or directory, then it's not empty. Therefore, it cannot be removed by rmdir, as we talked about, as we discussed earlier, right? Then what do we do? As we discussed earlier, we just put negative rf. You can just put r, but rf is another option, but both works. Okay. You don't have to put rf. You can put r, but anyway, both works. Okay. Then it will remove all the intermediate directories and files in directory. So if you do this, then you immediately see that there's no file directory anymore, right? New dir is all removed, including all the child directories, all the files, and everything. All right. Okay. Okay. How do you list the files in ls? Yeah. Well, you just do ls -l. Well, L is another option to show all the attributes as we talked about. And if you do this, and this is the result you get, you probably have done it yourself, and you might not have noticed what this is, right? Some of you may have, but some of you may not have. May not have understood what this is. It's actually permissions, right? Okay. And this is the file, the number of links, right? There's something called symbolic links, right? Okay, made to this file. It's like a shortcut. Symbolic links, it's like a shortcut in Windows. Hopefully you know what the shortcut in Windows is. But anyway, so which is a link to another file, right? Okay, this is the owner name, and this is a group name, and files. The 12 is a file size, and the date is this is the last modified date, and this is a file name. Okay, and there can be other, options in ls like these. Okay. Okay. One example is this. You might not have done this. What this example is doing, what this recursive function is doing, is that if you have child directories, right? Then if you use this function, this option, this will actually show you the entire files under all the child directories. Okay. Hopefully that's understandable. Okay. So suppose if you have a file here, so these are like some of the brain teasers here. Well, suppose if you have a file with a space in between, what will you do it? How will you remove it? Right? Because if you do this, the read command will take A and file as a different file, and it will not erase a file, right? So we're talking about a file with a space, with a space name including a space, right? So it's a space and a file, right? So if a file has a name that includes a space, what happens, right? You cannot do this. Okay. 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 So what you have to do is, okay. So what you have to do is you have to do this. Okay. So what you have to do is you can either, okay, so what you have to do is, in order to indicate a space, what you can do is you can use a backslash and a space. And backslash is called the escape character, which actually indicates a special character, right? So backspace followed by space will be interpreted as a space, okay, in the file name, okay? Or you can also do this, okay? All right. And if you put an asterisk after A, this is another way to remove it. Is another way to remove this is to do this, where what this asterisk means everything, right? So this basically removes everything with a name starting with A followed by 0 or any other characters. Okay? So this will actually remove this as well. Okay. Not specifically this file, but anything that applies to this pattern, right? Then there's another quiz where how do you remove this? You might want to search and try it yourself. Okay. 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 Let's look at permission here. Okay. So so file permission is represented by 10 characters here. right? Where this is the file character type, the file type. If it's a dash, it means just a regular file, any file. D means directory. I is a symbolic link. As I indicated before, as I described earlier, symbolic link is just like a shortcut in Windows. Okay. Right. And so these are all permissions. Okay. So these are all permissions here. And R indicates readable, W indicates writable, X indicates executable. Okay. And where, okay, where you can, the way you have, where you can define in Linux, you can define 3 levels of privileges. Okay, 3 different, 4 different, 3 levels of privilege. Let's say levels of privileges, where for one is a user, for yourself. Okay, so for the owner. Okay, and the other is a group within the same group. Okay, and this is for everyone, for others, for everyone else. Okay, all right. Okay. What does this mean? Okay, for the owner of this file, this program is readable, writable, and executable. Okay. For anyone within this group, they can read and execute, but they can never write. They cannot change the file. Okay. And for others, they can read, write, and execute. Okay. And we typically use octal representation or octal representation. So 1, 1, 1. So if you want to set all these to all ones, so 1 means enable, 0 means disable. Okay. So if you do, for example, so R is enabled, right? So if it's not enabled, it's expressed in a dash, right? So if you have R, that means if you have R, that means it's readable, right? So in binary, we represent it as 1. Okay, where this is not writable, so it's 0 here, and executable, that means we have 1 here. Okay. So if you read it in decimal, it becomes 5. Okay, and here, if you read it in decimal, it's 0 and 0. Right. Let's look at how this is shown, right? So these are some of the examples here. Okay, so you can actually see that this is a file and this is a symbolic link, right? This file, this link is linked to this file. Okay, so you can, if you want to access this file, you can actually access it through this link, right? And you have, and this is another file, and this is a directory. Okay, and you can see the different accessibility to different users, groups, and others. Right? By the way, this is an owner, is a group, right? Right. Okay, so in some cases you might want to change. So there's a question about what is meaning of the meaning being in the same group. So for example, if you might, there are some cases you might want to have a different groups, right? So if you might have, in this case, you might want to have a group. You might want to define your group of professors, right? Which may share some privileges, right? So professors should be able to access this file, where students should not be able to access that file, right? There should be some case there are some cases where you want to have that kind of group, right? Right? In those cases, you should make your own group in order to do this, right? Okay. Hopefully that answered your question. All right. Okay. So chmod is the change of mod. So if you want to, meaning that change of the mode, right? So suppose if you want to change the permissions, then this is the code that you use. Okay. Okay. There are different ways of using this. Okay. For instance, format is so you can use plus, and you can to add the permission, and you can use negative to remove the permission. I need to move a little bit faster. Okay. Suppose if you want to if you if you do this, for instance, then what this is doing is that for the group, you're adding the right permission of this file. Okay. Okay. All right. What about this? You're extracting this accessibility permission for group and others for my home directory. Right? Okay. All right. Okay, so so it also supports octal mode. Another way of using chmod is this, right? So you can, for first digit indicates for owner, second digits for the user, right? And second digit indicates for the group, and last digit indicates for the other, right? And this follows this number here, right? All right. Okay. Ooh. Okay. So what is the default? If you generate a file, the base permission for newly created file is 77 for directory and 666 for a file. Okay. And if you want to change the default behavior, you can do this. Okay. Use something called umask. Okay. All right. And this is how you can do it. Okay. So basically, it actually it basically is how you access it is that you actually subtract the permissions that you don't want, okay, that you don't want to give as a default. Okay. All right. Hopefully that's understandable. Okay. By the way, if you type umask, you will actually have 4 numbers, right? You actually get 4 numbers when the first one is for this, and which you can ignore for now. Okay. All right. Okay. Let's move on. So so let's well, well, nothing new here. Okay. But this is basically just telling you that you can actually set the direct permission for directory as well. Okay, let's move on. Whew, okay, we have limited time. I have to stop here. Sorry for this. I have to ask for your understanding. Let me just go on for the next 5 minutes. I'm very sorry. This won't happen again, but I need to finish it because then the next lecture will be taught by Dr. Yun, and I don't want to pass it over to Dr. Yun. So let me just go over and finish this lecture, okay? Sorry about that. Finding files. So this command is to find the files in the in the finding the matching file in this path where it actually finds it recursively. Okay. So if you do this, this will actually find a file with this pattern within the current directory, and also the child directories. Okay. And if there are different options to do this, you can set the file, you can set the data size, and so on and so forth. Okay. When you're trying to find the file, right? Okay. And another way is to locate the file names, is to use the locate. So you can also use, instead of which, you can also use locate and GCC 209 as well. Okay. All right, let's move on. So comparing file diff actually shows the difference between file in 1 and 2, right? Suppose if you do this, it actually shows the difference in this, and where here 3C3 means line 3, right? Has changed. Line 3 of the input, the first file, and the line 3 of the second file has changed. Okay, right? This is what it's saying here, and it actually shows the difference. Okay, and S difference actually shows it more visually of the changed of the difference. Okay, searching in files is a grep, right? In the file, if you want to search for this pattern, you can use the grep, and this is a very widely used. Okay, if you and there are other options. Okay, case insensitive, and if you want to find that it does not match, you use V and so on. Okay. Again, I'm not going through all the commands. I'm not going to go through all the options. Okay. There's no time for this. There's IO redirection. You probably have. I think you have experience of this in your homework, right? Where it redirects the standard output input or error of a program to and from a different location. So example is this. So if you want to output, instead of outputting the result of this program onto a monitor, if you want to output it onto a file, you do this. Okay. Instead of reading from a keyboard, if you want to read it from the file, you do this. Okay. If you, instead of outputting your error on the monitor, if you want to output an error to a file, you do this. Okay. And this is the difference. Okay. And if you do this, you concatenate. If you just do this, you always overwrite this file, right? But if you do this, if you do 2, then it actually appends. Okay. Pipe is what pipe does is it takes the output of this into input of this, and that is what pipe does. So what pipe is doing is that if you want to combine different operations of different commands, then you use grep, then you use pipe. Okay. So you can actually combine, make a combinations of many different commands, so that you get your own the expected output. Okay. Okay. And these are not all commands are covered, and please try them yourself. And now let's talk a little bit more about how to install GCC 209 on your local machine. Okay, since you have learned everything now. Until now, our suggestion was to code your program on a C, type your program on a VS Code on your machine, but upload it on the server to compile it, right? But you can actually, if you have your own Linux, you can actually run the GCC 209 on your machine, right? Of course, but you still have to test on the server before submitting, but you can at least run GCC 209 on your machine. Okay. How to do it? You download GCC. You now know where it is. You can download it, a copy onto your folder. Okay. Okay. Of course, you can put it on the under bin as well, right? Okay. But you copy it on the on the folder where it is included in the path variable, right? Any folder that is included in the path variable is fine. Okay. Okay. Or of course you can write your own GCC 209, which is just a text script. All you have to do is write this. Okay. And then you might have to make it executable. You have to make it executable, okay, by using chmod. Okay. And this is assignment for sorry for going over a lot of minutes now. Sorry. Again, sorry. Hopefully this won't happen again. Okay. So the assignment for lecture 2, I've actually changed the deadline to the midnight so that it's not confusing between EE209, right? Just so that we make consistency with EE209. Okay. And it's due next Friday, within a week, right? And this is what you should do. Okay. And you can do this on either on a server or on your local Linux, your choice. Okay. All right. So in order to do this, you will have to go over and look through the the commands that we have talked about. Okay. There's one question about. So you are free to leave if you have any questions. I'm here to answer. Okay. Sorry for going over the time. Enjoy your lunch. Okay. Thanks for listening. Okay. There's one question about, is super user and the root same meaning here? Yes. Any other questions? Okay. 이두형? Yes. Go ahead.
교수님, 달러 사인이 들어간 이 명령어는 차이가 뭔지 혹시 다시 여쭤봐도 될까요?
environment예요. environment. 그러니까 path. 그러니까 이게 path라고 하면 이걸 빼고 쓰면 maybe I need to explain in English. So the question is, so what is the meaning of dollar in the environment path, right? So if you don't put a dollar sign, then the shell is not able to tell if this is actually if what you mean is an environment variable, right? So in order for you to let the shell know that this is a path, the environment variable, you have to put a dollar sign. Okay, thanks. Any other questions? Okay, I'm still here, so I'll mute myself and turn my video off, but I'm still here, so please feel free to ask, okay? Okay, I guess there are no other questions, so I'll end here today. Thanks for listening. Enjoy your weekend. See you guys next week. Bye-bye.